Bringing you the IM351 extra practice number 4 solutions, and this one involves a puzzle, so let's take a look at that. So here's the puzzle associated with this extra practice. In this one we're trying to solve the riddle of what do you get when you cross a hummingbird with a doorbell. And to solve this riddle we have to solve each of these equations here by factoring and then match our answer to one of the letters over here on the right. Once we've got that letter, we just put that above the space with problem number down below here. So for example, if I did number 1 and I saw that the solution was D, I don't think it is, but let's say that it was, then I would put a D above space 1 right here. So let's go ahead and see what this is all about. So here we go with problem number 1, trying to solve the equation x cubed minus x equals 0. And our strategy on this one, and really all of the problems, is going to be to factor it down to the quadratic or second power level of x, and then generally solve that by square rooting, or if we have to, quadratic formula. Just looking at these answer choices here, we've got some imaginary numbers, we've got some radicals, so definitely I need some square rooting on some of these problems. So for this first one, first I'm always looking for common factors, and I see that I can take an x out of everything on the left here. So let me do that. That leaves me with x squared minus 1. And now I can set each of these equal to 0 and solve. So I've got x equals 0. That already gives me a solution right away. And then if x squared minus 1 equals 0, I can say that x squared equals 1. And then I'll square root both sides. Now when I square root equations, remember we need a plus and a minus. It's not built into the square root, but we need it to get both of the solutions. So in this case, the square root of 1 is just 1, so we have plus or minus 1. So 0 and plus or minus 1, that is choice I right here, so that's what I'm putting above spot number 1 here. For number 2, they're already giving us a problem that's not in standard form to start with. So if we're going to have any hope of factoring this, we need to get 0 on one side of all of the equations that they throw at us. So I'm going to subtract 3 in this one, just so I've got that all zeroed out. And now I can use my zero product property later on. Now I notice here that we've got quadratic form. This is x to the 4th, x squared, and a constant. So I can factor this just using x squared instead of x in my parentheses. To factor this one, it's a pretty straightforward kind of factoring. We have a 1 for the lead coefficient here. So I'm just going to be looking for factors of -3 that add up to -2. And for that, I've got 1 and 3 is really my only choice, but I'm going to make 1 positive and 3 negative. So I can split this up into x squared plus 1 and x squared minus 3. Setting each of these equal to 0 and solving, for this first one here, I can say x squared equals -1. And then if I square root both sides, since I'm square rooting a negative, I have to take out an I. And the square root of 1 is 1, so we have plus or minus 1i for that branch of solutions. For this next one, I can add 3 and square root both sides there. So that's going to be just plus or minus square root of 3. I would simplify the radical if I could, but 3 is not a perfect square and has no perfect square factors, so that's as good as it gets. So we have plus or minus I in root 3. That's choice E right there, so let me put that above spot number 2. This third problem is a little bit of a doozy at first glance. You're probably not used to seeing radicals in polynomial sort of problems. This technically isn't a polynomial since x to the 1/2 isn't a whole number exponent, but we can work with it anyway. This is actually a kind of a special case of quadratic form, where your first exponent is twice your middle exponent, and you've got a constant in only 3 terms. So we can basically factor this using radical x instead of x. It's kind of weird, but we're just going to be solving it later on anyway. So let me find factors of -7 then that add up to +6. So that would be 1 and 7. That's our only choice. We need a -1 and a +7. So I'm going to factor this into radical x minus 1 and radical x plus 7. And if you're really skeptical, I mean, you can multiply this back out. The 2 radicals give us just an x if you multiply them. We have a -7 radical x and a or actually a positive 7 radical x and a negative 1 radical x that add up to your 6 radical x in the middle, and then negative 1 times 7 gives us negative 7. So we're going to see some other weird cases like this on this puzzle. So now setting each of these equal to 0 and solving, there's a little bit more trickiness here. So I can say radical x equals positive 1 if I add 1 to the other side. And then to undo the radical, I have to square both sides. So that gives me x equals 1 squared, which is just 1. Now we have to be a little bit careful here because when you square a radical, you sometimes lose some information. You can get extraneous roots. So if I plug this back in, is square root of 1 actually equal to 1? It is. So we're actually all good on this left branch here. Now for the right branch, we have radical x equals negative 7. And if I square both sides there, I end up with x equals 49. However, if I take the square root of 49, if I plug it back into this equation, that is not negative 7, it's positive 7. So this is actually an extraneous root and won't appear in our answers. So the only answer we get out of this is just x equals 1, which is going to be choice M here for spot 3. For this one, we're not in standard form, so let's start by subtracting that 81x over to the left side. And I also noticed that I can take out a common factor of x, so let me do that. That leaves me with 16x to the 4th minus 81. And now for this stuff inside here, so I can bring down the x, let's keep bringing that down. But for the stuff inside here, this is actually a difference of squares. This is an a squared minus b squared kind of situation. So I can split this up by square rooting each of those and putting a plus and minus in my parentheses. So the square root of 16x to the 4th, that's going to be 4x to the 2nd, because we're dividing the exponent by 2. And then square root of 81 is 9. So I have 4x squared plus 9, 4x squared minus 9. Now that I've got it down to the quadratic level, I'm just going to set each of these equal to 0 and solve them. So we have x equals 0. That's one of our answers right away. Next up, I have 4x squared equals negative 9 if I subtract the 9 first. And then I can divide both sides by 4 to get x squared by itself. So I have negative 9/4. And then finally, I have to take the square root of both sides. When I do that, I'm going to have to take out an I because I'm square rooting a negative. And the square root of 9 over 4 is going to be 3 over 2. We can square root the numerator and denominator individually. So I've got plus or minus 3/2 I. Next up, let's set this next one equal to 0. So we can say 4x squared equals 9. Divide both sides by 9. And now square root it. I've got plus or minus just plain old 3 over 2. So kind of like this first one, but without the I. So we have plus or minus 3 over 2 and 3 over 2i. That's pretty easy to spot. That's up here. It's also got that answer of 0. So we're putting an r above 4. For this problem, I noticed that we've got 4 terms. So I'm thinking some factoring by grouping would work out pretty well here. We're already in standard form, so don't have to worry about that. Looking at my first 2 terms, I think I can take an x to the 4th out of both of those. That's the smallest exponent. So if I do that, that leaves me with an x squared, 6 minus 4, minus 25. And for the next 2 terms, I can't really take out a whole lot there. I can take out a negative 1, so I'm going to do that. That leaves me with a positive x squared minus 25, which matches my other parentheses. So my x squared minus 25 comes out of everything there. And then the x to the 4th minus 1 goes back into a parentheses. And now I can set each of these equal to 0 and solve. Before I do that, though, actually, let me split this x to the 4th minus 1 up a little bit. I want to get things down to the x squared level before I rely on setting things equal to 0 and solving. So this x to the 4th minus 1 is actually an a squared minus b squared kind of situation. So let's see, I've got the initial x squared minus 25. I'm not going to actually bother using the shortcut on that, although I could. But this one, the square root of x to the 4th is x squared. Square root of 1 is 1. So we have x squared plus 1 and x squared minus 1. Now I'll set each of these equal to 0 and solve. So we have x squared equals 25. Square rooting that, we have x equals plus or minus 5. Next up, x squared equals negative 1. So then x equals plus or minus I. We already kind of did that in a past problem. And then x squared equals positive 1. So square rooting that, I have x equals plus or minus just plain old 1. So we end up with 6 different answers. They're all in choice D right here. So that's going in spot 5. This next problem looks innocent enough. I mean, just 2 things going on here. This one's kind of epic though. So first I'm going to start by getting this in standard form by moving that 625x over to the left. And I also notice that I can take out some common factors. For the numbers, I can definitely take out a 5 from both of those. And I can take out an x as well, so 5x. If I do that, I've got an x cubed for that first term. And the next one, 625 divided by 5 is 125, so we have a minus 125. Now, one thing I also notice, this 5x is going to have to come down, but one thing I notice is that I've got 2 perfect cubes with subtraction going on. So there's actually a difference of cubes factoring shortcut that could help us out. So here's that shortcut. A cubed minus b cubed is all this stuff, a minus b, a squared plus ab plus b squared. So basically you just have to cube root the 2 things that you see in there and apply this formula. So let's go ahead and use that. We've got the 5x already, and now the cube root of x cubed is just x, so a is really just x, so we have x minus, now we need the cube root of 125, that's going to be 5, because 5 to the third is 125, so minus 5. Next we have a squared, that's going to be x squared. ab is x times 5, so plus 5x, and then b squared is really 5 squared, so plus 25. And we can actually go through and set some of these equal to 0 and solve now. So if 5x equals 0, then x equals 0. And then for x minus 5, we just have x equals positive 5. And then we have whatever zeroes out, x squared plus 5x plus 25, which I'm kind of out of space. This is definitely going to need quadratic formula. I can't think of 2 numbers that multiply to 25 and just add up to 5. So I'm going to do that on the next slide. So here we go, next slide. Again, we had 0, 5, and this equation to solve is kind of the conclusion from the last slide. Now let's go ahead and use our quadratic formula. So here it is, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So since this is already in standard form, I can just go left to right and take out my a, b, and c from what I see here. So negative b, that's going to be negative 5. And then we have square plus or minus square root of 5 squared minus 4 times a value of an invisible 1 here times a c value of 25 all over 2 times the invisible 1. And let's do some simplifying. We've got negative 5 outside here. We've got 2 in the denominator. Inside, I've got 25 minus 100, which is negative 75. So that's as simplified as we can get in just kind of one step. But now I need to go a little bit further. So I'm going to take out an I right here, and I can also split this up into 25 times 3. Square root of 25 is going to be 5. So that's going to be negative 5 plus or minus 5i radical 3 over 2. And looking for all those answers, we got these 2 plus the 0 and the 5. That's all answer H right there. So at long last, we can put that under spot 6. Here we go with problem number 7. If you thought the last problem was wild, this one's really nuts. So we've got these negative exponents going on. The key on this one is to recognize that this is actually quadratic form. My first exponent is twice the second exponent. So we can go ahead and factor this just using a negative 1 instead of, or an x to the negative 1 instead of an x. So to factor this, let me use my AC method. We've got 2 times negative 3, giving me an AC of negative 6. I need factors of negative 6 that add up to negative 5. That would be positive 1 and negative 6. So I'll split up this middle term into a positive x to the negative 1 minus 6x to the negative 1. And now with 4 terms, I can go to grouping. So for the first 2 terms, I can take out an x to negative 1. That leaves me with a 2x to the negative 1. And if you're a little confused about the exponents there, When you're taking out a term, you're actually dividing. So we have x squared to the negative, or x to the negative 2 divided by x to the negative 1. That means we're subtracting the exponents. So negative 2 minus negative 1 gives me negative 2 plus 1, which is negative 1. And now taking x to the negative 1 out of itself, we get a plus 1 there. More straightforward for the last two terms, we can take a negative 3 out. Leaves me with a positive 2x to the negative 1 plus 1. And then 2x plus 1 can come out of everything, leaving me with an x to the negative 1 minus 3 for my other factor. Setting each of these equal to 0 and solving now, this first one I can say 2x to the negative 1 plus 1 equals 0. And if I subtract 1 and then divide by 2, I've got x to the negative 1 equals negative 1 over 2. Now this one's a little bit tricky, but if you raise both sides to the negative 1, that'll give you just x. And when I do that, I'm basically flipping all my fractions, inverting all my fractions. So this gives me x equals negative 2 over 1, or just simply negative 2. Now for this next one, I can say x to the negative 1 minus 3 equals 0, so x to the negative 1 equals 3. And if I raise both sides to the negative 1, take the reciprocal, I end up with x equals 1 over 3, because we initially started with 3 over 1. So 1/3 and negative 2 are the answers I'm looking for, and that's going to be n. So there we go for spot 7. Problem 8 is also kind of crazy looking, but it's not as bad if you understood what we did back in problem number 7. It's the same kind of idea. We've got these weird exponents, but this whole thing is actually quadratic form. The first exponent, 2/3, is twice the second exponent of 1/3, and you've got a constant. Whenever you see that situation, you can always factor it or try some kind of quadratic math using x to whatever the middle power is. So in this case, we're going to factor it using x to the 1/3 instead of x. And if you're curious, x to the 1/3 really means the cube root of x. So I'm going to need AC method for this one. 3 times negative 6 is negative 18 for my AC. And then I'm using factors of negative 18 that add up to negative 7. So 1 and 18 doesn't work. 2 and 9 works if I have a positive 2 and a negative 9. So I'll split up this middle term into a plus 2x to the 1/3 minus 9x to the 1/3. Now let me go ahead for some grouping. For the first two terms, I can take out an x to the 1/3. That leaves me with 3x to the 1/3, because again we're subtracting the exponents, plus 2. For the next two terms, I'll take out a negative 3. So that leaves me with a positive 3x to the 1/3 plus 2. 3x to the 1/3 plus 2, that's all coming out as my common factor. And then x to the 1/3 minus 3 is the other one. So setting each of these equal to 0 and solving. So here's our first parentheses equal to 0. Now I want to get this x to the 1/3 by itself. So to do that, I'm going to subtract 2 and then divide by 3. So negative 2 over 3 on the right side. And to get rid of the 1/3 power, I'm going to raise it to the reciprocal power, which is the 3 power. Because when I raise both sides to an exponent, I'm multiplying these exponents together. So I've got x on the left equals, and then I have to do negative 2/3 to the third. So I'm going to raise the numerator and denominator individually to the third power. 2 to the third is 8, 3 to the third is 27, and it's an odd number of terms, so the negative gets preserved. So we end up with negative 8 over 27. Over here on the right side, it's a little bit easier, setting this thing equal to 0, adding 3 to both sides. Now I just have to raise both of these sides to the third power, just like I did over here on the left. 3 to the third gives me 27 for my other answer. So we've got negative 8 over 27 and positive 27, and that's going to be choice A. So that goes in spot 8, and that's our very first term. For number 9, we're going to follow the same kind of pattern as the last two problems. Weird exponents, but we are in quadratic form. 1/2 is twice 1/4, and we have a constant. So I'm just going to factor this whole thing using x to the 1/4 instead of x. The factoring on this is a lot easier. We have a 1 for the lead coefficient, So I'm just looking for factors of -4 that add up to -3. So that would be just 1 and 4, +1 and -4. So I have x to the 1/4, and then I'm going to have +1 and x to the 1/4 -4. Setting each of these equal to 0 and solving, I can write x to the 1/4 equals -1. And to undo the 1/4 power, I'm just going to raise both sides to the 4th power. So -1 to the 4th gives me x equals 1. We got to be a little bit careful though, because if I plug this back in, this is actually the 4th root of x. If I plug this back in, the 4th root of 1 is +1, not -1. So this is actually an extraneous root. I don't get to keep that answer. For the next one, I can write x to the 1/4 equals 4, and then raise both of these to the 4th power. So that's going to be x equals 256. And the 4th root of 256 is 4, so I can keep that answer of 256. So then that's going to be, let's see here, we've got 256 is the only answer, so that's going to be choice G going in spot 9. So again, I keep that answer, G in spot 9, and we move on to the final problem. Here we go, final boss battle. After those last few problems, you're probably thinking this is going to be pretty awful. It actually isn't so bad. Let's first get this zeroed out in standard form by subtracting 4 radical x. And now these terms both have x to some power, so we can actually take out a common factor. The common factor I'm going to take out is going to be x to the lowest power, which in this case is going to be x to the 1/2 or radical x. If I take radical x out of x, x divided by its own square root is just going to be another radical x, and then -4. Setting each of these equal to 0 and solving, we can write radical x equals 0. So squaring both sides, I get x equals 0. And then the square root of 0 is 0. So that answer checks out. And then we can say radical x equals 4. Squaring both sides, I get 16. And then the square root of 16 does equal +4. So that answer also checks out. So we end up with 0 and 16 as my two answers. And that's, I believe, the only answer choice left is U. So that's going in spot 10. So we've got all the letters filled in. Now we're just going to try and solve the puzzle. What do you get when you cross a hummingbird with a doorbell? So this all looks like a lot of letters, but it's actually only 2 words. We've got an and then humdinger is all one word. Now, if you're not really sure what a humdinger is, that's like something that's really remarkable, like, wow, that's a real humdinger of a puzzle. Maybe you don't think this is a humdinger of a puzzle, but in any case, we solved it. So until next time, Mr. Sutton signing off.